So hello, good evening everybody, and welcome to another video. And tonight we will basically do something a bit different from normally. So as you see, basically I prepared here a little bit of this stuff. What we will talk today about is basically ChatGPT. So if you don't live on another planet, or if you don't read the news, basically you probably heard about ChatGPT, which is a new AI that you can talk to basically on the internet. So you write in questions and it gives you answers, and it's incredibly well suited for programming. And what I will show you today is basically, I don't know how far we will get, or how well it will get, or how this video will end up. But what we will try to do tonight is basically, I will try to write a PDB visualizer, so a program which visualizes a PDB file in 3D on screen with this new AI, and I will show you how this basically will work, and how the future will change, basically how we will program in the future, because I tried this out this morning and I thought this is just incredible, so I have to make a video about it. And we will do a session here, which I will probably call, let's say, an AI-assisted programming session. So I have our little AI chat window down here, so I can ask questions in here. I hope this all won't break down. I already prepared here my Emacs window with basically with my with some C file that I just opened, which is still empty. Where we will write this program, and so let's get started. Let's ask the AI basic question. Can you help me write this program? Yeah, so can you help me to write a C program? So you see, this is basically the crazy story about this. You talk to this thing like you talk to a human guy. Yeah, so and it's very it's sometimes very uncomfortable, sometimes also very relaxing. You have the feeling that you're like talking to a friend or something like that, but it's really kind of crazy. So can you help me write a C program that visualizes, we will be very explicit here, so that it basically knows what we're talking about. So we write it out: protein data bank file, there's a PDB file, protein data bank file. Let's be it like this, PDB file, so that he basically knows what we're talking about here. Using the STL library on screen in 3D. Let's get it started. Let's give it a try. So we asked our question, and it says sure. Okay, this is very helpful. Let's read what's coming out. So the necessary header files, yeah, okay, for handling PDB files. Okay. Yeah, we will need to initialize all that. So it basically gives us already a short overview about what we have to do, as you see. Maybe I can make this here a bit bigger. So just recapitulate what's going on here. So he already named our chat here. I guess I will change this arrangement a bit, like put our C file here, chat with it here, so that we have here a bit more space. And you see basically what it says. So we should basically include the necessary header files. You can read all this here. We need to parse the PDB file in the XYZ coordinate, of course, and we want to draw it. And basically, let's do this. So let's do this basically. So let's start basically with parsing the PDB file. So what would I do? So it says XYZ coordinate. So this is basically a chat. So basically what I will do here is can you show me an example code? Let's say it for points 1 and 2. Yeah. Or can you show me a piece of code for point 2 And here we begin. So here he creates a data structure. And here he writes code how to parse this. So that's pretty nice. Well, I have here a structure that's cute, but that's still not what I want. So let's say it like this. Parsing the PDB file. So what I basically need is, well, I need to know the atom type, and I have in my head basically that I need the van der Waals radius so that I get basically the right size for each atom. Yeah. So what I will ask it, recreate the structure so that we have the atom type basically stored, because here we have atom name, but basically there's like this last line where you have this atom type from which we can then derive the van der Waals radius. If you know about the PDB file structure, I'm not sure about it, but you basically can read it from here. So this looks already pretty cool. We won't copy paste this right over here, but that's what we basically what I want to do is to have the AI write a program. But we will slowly get there because we will ask question after question, and you will see how you already see that it can write this code for me. That how we get there. So basically, what I will ask it is, can you change the structure for me? Yeah. Carbon, oxygen, nitrogen, something like this. What do we have here? We don't need occupancy and temperature factor, yeah, and omit occupancy. And then further C structure should be, and I want it to be dynamically allocated, because what you have seen here, he said max atoms 10,000. That's not what I want. I want just to have as much atoms as possible. Yeah, this is kind of is not what we really want. Yeah, it should be dynamically allocated. Yeah. So let's hope he understands the question. He already says certainly. So he already puts this right here, atom type, XYZ coordinate. Perfect. Yeah, we got our structure. Here he begins to think. Here he already writes me the parse PDB file. Open the file. I'm not sure if this scanf here is right. Puts the atom type here. I guess one could do this like that, but basically I already have this here, so we will copy paste this basically into our code. Yeah, so we already have here a PDB file parser just written from the AI, yeah? With the instructions that we gave him here. So what we do here is we type that here, copy code. We will yank this over here. I copied it right now 2 times. that's basically the way we want it. So this here is like the atom structure here. Very nice type, just as we asked for it. It's incredible. And we already have here the code how to parse basically the file. Yeah. So this is basically a function which does this. We copy this, we paste this in here. We have here our parser. We'll put this includes, of course, up there. And we have a PDB file parser without doing much. Yeah. So we just verify this a bit if this is correct. So it opens basically here a file name. That's pretty cool. We got this structure. We got this stuff here. We got all of this. Yeah. So that's pretty cool. That's pretty cool basically. So we got already a PDB parser so far. So the AI programmed this for us. Right now we still want to visualize it. So let's talk to the AI. Let's do this, no? Should do it for us, no? We're kind of lazy today. So I have parsed once we have parsed our PDB file, because he did it, no? No. Our PDB file. Of the structure. Spheres in 3D space. So he already colors it according to the type of atom. That's already incredible. He calculates basically the position there. And he connects them with lines. So he created this function. This is incredible. Yeah, you just talk with the AI does this for you. So as you have seen, what did he do here? So he basically wrote a draw atom function with a certain radius. Why the radius is an integer, I don't know. That's not what we want. What we want basically is that atom type. Yeah, that's nice. We will specify this a bit better, because he does this here with draw lines. Yeah, draw the atom field as a field circle. Yeah. Okay. With the radius, that's not basically what I want. Here's something like, yeah, in atoms draw render. That's nice, but that's still not what we want. Yeah. And there's nothing what we can copy from it. Basically, what I want is that each atom is drawn in 3D space according to its van der Waals radius. Yeah. So we will do this like that. So I will ask him first, can you get me a list of van der Waals radiuses die for atoms typically used in organic molecules. Yeah, let's call it like this because we don't need, I don't know, uranium or whatever. Yeah, you already get the idea. So here we have the van der Waals ready. That's perfect. Yeah, size of the cavity in a protein. That's way too elaborate here. I just want you to use this list. And right now I will ask him the question, well, use this list, update my draw atom function, you to a C structure, and update date. So it's a conversation, as you see. Yeah. So he knows what he has answered. Yeah. So I can tell him right now, update the draw atom function. Draw D space using the van der Waals radius corresponding to the atom type. So right now I have to ask if my question still makes sense. I guess so, yeah. Let's try it out, yeah. He puts the van der Waals radius into the structure. That's not what I wanted to do, but okay, yeah. He always insists on this float scale function here. Okay, so that's pretty fine. So we have this function, he updated this, he didn't include the van der Waals radius the way we wanted to have it, so he says just van der Waals, yeah. He didn't really get this, I guess. So so let's have him write this function. So the problem here is he didn't get it because he basically uses the atom name, which is not what we want to do. He should do this with the atom type, yeah, which of course is here CA and not COA, so here the AI fails. I mean, the idea is basically correct, but yeah, of course you get the idea, yeah. So here we get the C code for that, and that's not what I want, because basically what you want here is you want to have atom, not atom name, but atom type, yeah, because otherwise this is a bit stupid, yeah. Right now he got it. Yeah, so this is, as you see, even when he makes a mistake, you can correct him, and he corrects it. Yeah. That's what we need. Yeah. Switch cache function with all the radios is done. I don't need to write code tonight, I guess. He does everything for me. Yeah. I have my assistant write the C code tonight. So we will need this function. Yeah, that's easy to do. We got it. Yeah. That's how we will do it, of course. So we read all the atoms. We will put this into this function here. We already have the type here. He said what we need here is the atom radius, of course. He updated this already up there. We didn't do this. We need to do this, so we need this float radius there and there. So we will do this here. So we'll put here float radius. So we write a little piece of code. So this is why I call this AI assisted programming. Yeah, this is totally incredible, to be honest. Yeah, and so right now I have here this van der Waals radius function. So I will copy this here. Copy code. Set this down here. We will paste this here. Perfect. This is pasted. Include string h. We already have this here. That's the van der Waals radius function. And we will call this, well, after we did this here, no? What we will also do is unknown atom type radius. That's perfect. 1.5. You already thought ahead of it here. So this is something typical programmer mistake. Yeah. If you don't know the atom type, yeah. So we will put it here, and we will set the radius as follows. So we will have all the atoms here. So here is return atoms before he returns the atoms. The stuff is here. He reads all these atoms. He allocates them. That's nice too. Int num atoms. That's also fine. So he returns the number of atoms. Okay, we will write this later in this function here. So we will. Can we do this basically? Num atoms. Num atoms was already added here up to the number of atoms that we have. So what we will do is here we will add this function in here and update the atoms I. This is all valid C code. This is incredible. Yeah, we already got it here. Perfect. So here we update the radius just as he did it. That's nice. Right now I really want him to draw this, and he want him to set me up some STL stuff so that I can draw it. Yeah. So let me set up a main function for the program. Creates an STL window. In 3D space. Sets up. So, as I said, I don't want to program tonight. He will do it for me. So he begins, he sets me up the main function, parse the PDB file, set the van der Waals radius. I shouldn't do this, yeah? I shouldn't talk too much because he does it better than me. So let's keep him the function that he had, because otherwise this won't work. We remove this here. He creates my PDB viewer. Clear the screen, draw the atoms. Sure, he even gives me a little summary of what he does. This is incredible. So we will copy our main function down here into PDB visualize. Okay, so here the explanation, he stops. If you type continue, he continues. That's fine. Well, I got the code here, I guess. I will copy this code over here. So what we need here is the standard bool stuff. So we will standard IO. I'm not sure if you already have it. Let's copy this here. I copied this here. I don't have standard IO. Oh yeah, I have standard IO. So let's include this stuff here. Let's remove standard IO. He wants standard bool. I don't know where he used it. Probably somewhere for STL. Let's see if this works here. He initializes STL. Let's copy and paste all this here. And let's make this our main function here of our program. So set the scale. Why do we need this offset and scale this? We need this for the renderer somewhere here. Render atom scale. Okay. And scale is... I don't know why he sets this offset. It's an unused variable, no? In order to get the midpoint, but okay. I don't know what he's doing with these offsets here. Maybe that's an error in the AI. Let's try to compile this, no? So, how should I compile this now? with GCC. Let's compile it with GCC. I don't have a parse PDB C file. He believes we put this into 2 different files, but yeah, we got this, yeah, but yeah, we know how this works. I mean, here it describes us how we can compile this. Let's compile this as he says this, yeah. So let's do this mx compile. I will do this here directly in Emacs so that we can get the errors, because this guy is not perfect, trust me, but we will see. Maybe it's perfect. So PDB viewer, this not, so I called this here yeah, GCCO PDB viewer, of course. I called this here PDB visualize. It's not saved yet. Yeah, okay. PDB visualize STL2. Let's give it a try. Yeah, that's probably wrong, because this should be called STL2H, no, and not STLH, no. So we will correct him a bit, no? Can you correct your code? Is this incredible? So let's do this STL2RH, no? STLH. I hope the rest stays the same. Init STL init video, that looks pretty the same. That looks correct. That all looks correct. Didn't finish. The rest of the code. Yeah, okay, that's perfect. Clear the screen, he does this. This is incredible, yeah. We're compiling. Incompatible pointer type. So he has here parse PDB. We might have here an old type of, or maybe he was wrong. When did he write the last time this parse PDB function? Did I write the wrong, did I copy the wrong parse PDB function, or did he make a mistake? That's the big deal here. Here's parse PDB draw atom. So we still don't have the draw atom function, I guess, you know. So we didn't copy paste this, so I have to copy paste this over here. So we don't have this draw atom function. We also need this function that he has written us here to draw these atoms. Pretty cool, no? But as you see, nothing's perfect. Where's my parse PDB function? Okay. Not sure. And he corrects his function. So what we want to do here is we will just change this accordingly. So let's recompile this. There's still an error. Yeah, of course, these offsets here, there are these scales, and these offsets, they don't get into this draw atom function, no? I mean, yeah, Ah, yeah. So we will just do this here. So we will just add int offset x offset y as he's described it here. What is kind of lazy is that he writes this, yeah, it's a bad coding style, no? But that's the way it is. But I mean, it's like, that's not the coding style. I wouldn't like write lines long like this, but I could indent this, yeah? So basically, I wrote all the code tonight, no? That's incredible, no? And so right now, we're here, so he writes me this write offset function. Yeah, I guess that's the way we had it. Right now he adds here a lot of color, I guess. What do I have here? Do I have here unknown type? What does he say here? Other atoms are gray. Okay, so I'm fine with that, with the gray atoms here, yeah. I don't need chromium and whatever, yeah, that's nice to know, but yeah, orange and whatever, yeah, that's nice to know. But right now he uses a draw circle here. So I guess I will change this here. So let's copy this here and get this new offset function the way he wrote this. Let's hope this works, because we get way more out of it than that here. So you see he changes the idea how he does this. Let him do his thing. And compile this. Yeah, that's stupid, no? Yeah, of course I can do this, but that's a stupid idea. Yeah, right now he wants to do a string comparison, so let him doing this. Right now he crashed, I guess. Continue, please. It's too complicated for him. Oh no. And he's kind of a funky guy because he omitted this stuff, you know? Okay. So you see, not everything works as expected, so I will just remove the Cl and the bromide here and the I and keep it like that, no? Let's keep it like that. I mean, he did a good job so far, I guess, no? Let's keep it like that. Let's try to compile this. Let's see what we get for errors here. And we have an implicit declaration of STL draw circle. Did you mean STL draw line? Yeah, probably. That's what we had before. Too few arguments to draw atom. Okay, that's our fault here. So here we need offset x, offset y, offset z. No, I guess they're called offset. Yeah, offset x, offset y, offset z. Let's do this for him here. As I said, this is assisted programming, so that's here. That's correct. STL draw circle. That you have used. So, as you saw, he used the wrong. He used the function which isn't declared. Let's see what this is here. So he apologizes. That's so nice. Using STL draw line. Of course. That's what we had before. Oh, he does this STL draw circle. He creates it for us. I mean, how cool is that, no? We don't need to do anything tonight. The STL draw point. Oh my god. What are you doing here? So let's implement it like that. Where's his STL draw circle? Does this work with XY radius? What did he write here when he used STL draw circle? XY radius, that's fine. So well, let's just copy that over and implement this here. Didn't finish. So I hope that this works. I hope he didn't do any crap here. Because sometimes he omits lines, you know, you never know, but this looks pretty fine when I look here at these pluses and minus. And this seems like to be really this midpoint system here. Pretty cool that it's a midpoint algorithm. So we got this here. Let's compile this again. Compilation finished. So we got a program here, a PDB viewer. Let's try to call our PDB viewer. I don't have a PDB file here, but let's see. How did he want me to call this? Where's our main function? So parse PDB. It's the argument value 1, so it's the first argument here should be the PDB file. It's perfect. Let's do this. Let's download the PDB file. Let's head over to RCSB PDB. We're pretty tight here. Let's try the molecule that we have used in the other terms here, the 1UX6. This one here. Let's have this drawn with this algorithm. Let's see what comes out of that. I want to have here my can I download my file? I wonder if it won't crash, but PDB format. Okay. Right now have us wonder. PDB viewer downloads 1UX6 PDB. So we certainly have a viewer, but it doesn't update the screen. That's bad. So we have a non-functioning PDB viewer. I have the feeling it has crashed. No. Right now it's dark. What does it do? Yeah, it closed right now because I closed it. So it's coming up. Maybe the draw routine is pretty slow. I don't know. It doesn't look perfect. There's probably something wrong in the code. So as you see, maybe the AI is not perfect yet. Maybe I'm not perfect at interpreting its code. Let's see where I can find possible mistakes. So first thing that we will do is we will just draw in software and we will stop this stuff here. What is it over here? When he initializes the STL init, that's fine. He creates the window, he creates the renderer, that's fine too. In the window, let's use here the renderer software. It's a pretty slow. So, should we talk to him? Should we need his help? Update the screen while running. Ah, that's why he needs to spool stuff here. So let's create it. Yeah, that's how we want to do it. Clear the screen. Draw the atoms. So let's do this. Add the STL delay. That's for the atoms. Probably my scale is wrong. So let's recompile this here. It looks good. Where's my terminal here? So the question is it presented here? Because he sets the renderer, he clears the renderer. After STL draw color, coordinates so that the molecule fits into the screen. Okay. Yeah. Yeah, he stops here. That's not what we want. Oh my god. Sure. Yeah, okay, about the scales and the offsets, please. Okay. So do this correctly. Come on, guy. Yeah. Nah, man, you got it. Then we will include that, copy it over, and hopefully we see something on the screen. Otherwise I give up here. But you basically get the idea how this works, no? So let's give it another try. I still have a problem with rendering because, as you thought, we still don't have it. Yeah. Perfect. So we will copy paste this code here. We will copy this code, of course, into our stuff here. We need this little function here. We will paste this here. That's pretty nice. The question is what we will do with the depth here. Initialize SDL. Okay. He should do this for me. Now he uses a new declaration. What is this? Why do you use molecule PDB here? What is it for a crap? Right now he gets lazy. Yeah, STL renderer, create renderer software. That's perfect. That's what we have here. He forgot that last time. So we will update that here. Screen height, that's perfect. And here we have STL window shown. Okay. This is incredible, no? So screen depth to 50. He even thinks about rendering time, that's incredible. So let's put this in here. What are common screen sizes here? Oh yeah, what are common screen sizes here? So let's put it here. Oh yeah, there's I don't know anything here. This is way too big. Yeah, let's make this 1000. I don't care. Let's make a square viewer here. And depth 50. Let's try this out. Did I still compile? Fmax. Ah, it misses the math library right now, no? Compilation finished. Let's give it a try. Where's my formal window here? No, that's not you. That's where we record all this. Okay. Maybe it was this. Maybe I closed it. Whatever, PDB viewer. Does this use any CPU actually? Yes, it does. Or is this just my recording using so much CPU? Hey! It's just damn slow. I mean, that's not nicely centered. And that's not nicely scaled either, but we're coming up with something. And these circles, these are crazy, but I would never implement it like that, but as you see, we are coming close to PDB viewer. So let's do this bit better here. It takes so much memory, what's going on here? Let's see how long we are already recording here. No, we are already at 1 hour 14. Let's get to the finish here. To be centered in our code. Can you fix that? Yeah, let's update it. You should do things correctly. So, that's pretty cool. So he understood the problem. Let's copy this code. Where's my PDB viewer Emacs? Where's my Emacs here? PDB visualize. Here's my Emacs down on the screen. And right now we will update our code here. Damn, my hairstyle is getting crazy, huh? But let's get it done here. Okay, here still we have these offset values. Why are we doing this that way anyway? Didn't we tell him to rewrite our function here? Maybe we just got this wrong scaling stuff here. We didn't call the function, no? Okay, so first what we will do is we will use the new calculate. We'll trash this here. And we will use the new calculate and offset code here. Copy the code. Yank this in here. Is this the new code? This looks like the new code. Okay, the new scale and offset code. And here we have this calculate scale and offset. So I didn't have this in the main function over here. Where did you put this? Set calculate scale and offset. Screen depth, screen width, screen height, screen depth, num atoms. I need the num atoms. That's all I need. So we will trash this here. I guess this SDL window shown is necessary, to be honest. Not sure about it. I would have to look it up. But this guy does such a great job. Let's give it another try. Let's try our PDB viewer. Let's copy this line over here. Let's compile this. And let's run our PDB viewer. Oh, whoa, whoa. This doesn't look good. This looked better beforehand. Is it calculating something? Did I save this before? Yeah. With a lot of CPU power going on. I'm not sure what it does, huh? So it looked already better, huh? Yeah, right now we would have to debug that. I mean, we got pretty far. I will stop the video here, I guess. Let's try a bit. Let's try a bit around still. Did I do this right? Screen width, screen depth, screen height, screen depth. Let's use a screen depth of 100. Maybe my screen depth is too bad. Don't change anything, to be honest. Now we don't see anything. Now we have the same artifacts as before. That's not what we wanted. So what was the old code? Let's not use this function, let's use the old code. It takes a long time to render here. And let's do this manually to get this right here. So this looks pretty good, no? So let's put the offset put more offset there. Let's not calculate the offset as he does. I guess he's made an error in there. Offset Y. How does he draw this here? When he does draw atom. Yeah, he puts these offsets here. And the scale. Do you have a scale here? And you have a scale, so let's do this here a bit different. Let's do the scale to 20, something like this. Let's put these offsets to the half of it, or maybe at least the Y. Let's put this to 100. I guess he gets these calculations completely wrong here. But that's why we still need to do our job, no? And let's retry this here. Close it. It takes so long to update the screen, that's why it's like very slow here. That's a very slow renderer, to be honest. But yeah, of course it's not optimized written either. But so we have to recompile this here. That's my PDB file. So I'm pretty happy with that. Maybe if I put a bit more X offset, then we get the molecule really to be rendered in on the screen. Let's try that out. Let's get the X offset. X offset's 320. What if I put here 520 in here? 100 in here. Let's make it even a little smaller here. Yeah, this 50x offset, this doesn't work. Let's say, come on. Or is this the Y offset? I have no idea what's going on here. Does this he want this? What does he want it? If I do here 200. Come on, get me the molecule centered. I have the feeling these offsets, they don't have any effect. Yeah, I don't compile this again. I'm stupid. I mean, I have to save and compile this here all the time. Yeah! We managed to render a PDB file, no? I guess that's the way we do it. So, let's stop it here. I have an AI written PDB viewer right now. That's all I wanted. Well, the PDB file, it's not pretty nice, but you have shown how you can have AI write your code. That's perfect, no? So, I stop it for it. I guess that's enough for today. I guess we had a lot of fun. I hope you had fun as I did. And that's pretty it. Have a good night.